In this video, I'm going to discuss and introduce electric current. So we're going to talk about electric current. So we're no longer talking about static. This is electrodynamics. Now we're talking about electric charges in motion. Charges in motion, right? Let's define electric current. Electric current measures how much charge flow per second. How much charge flow per second. So how fast? How much charge flow. We use I typically for current. And that's equals to change in how much charge flow per time period. So from here, you can see that a unit will be coulomb per second, but we use a unit for current as amperes. So this is amperes. So 1 ampere equals to charge per coulomb per second. This is what the electric current is, to see how fast, how much charge flow. Okay. So when do we see electric charge flow? When do we see electric charge flow? Example, we can use the analysis with the gravitational force. When the object moves from the gravitational, due to the gravitational force, right, is when you have a height difference. So you could be on top of the slope or something. When you have the height difference, object will move from higher gravitational potential energy to lower, right? It flows from high to low. Same thing happens with the electric charge. Electric charge, let's see. Electric charge, it's better to use the little, always it's easier to use the positive Q. So let's use the positive Q. Moves from higher potential. So that means that V is high. This V1 is higher, and this is in voltage, right? Move from high to low. to lower potential, V2. So here, V1 is higher than V2. Then plus Q will move from high to low. We know that it's conductive electrons, which is negatively charged particle, right? In conductive material, that is the source of current. The source of current is the electrons, free electrons. And then when you have a potential difference, it will flow. So let's see. Actually, the negatives, E plus. So when the E plus flows from high V1 to low V2, E minus moves from low V2 to high V1. So conventionally, we use the positive charge. Conventionally, positive charge is the flow, current flow, electric current. So this I is the positive charge, but it is reality. It's in reality, it's the conductive free electrons, which is negative. It's the motion of the free electrons. But we use that positive charge. So when the electrons moving from low to high voltage, you can think that it's the exact same amount of charge that's moving from high to low voltage. It's just easier that way. So from here, you can see that a current is established. And current, again, is for the positive charge. And current is established when you have a potential difference. And also closed circuit. So imagine that you have a, let's say, here's the 9 volts battery, plus and minus, right? And then you put a light bulb. Light bulb will lit when you close the switch. Then it will lit. The current will flow from plus to minus. When he says 9 volts battery, that means that here, let's say this position and this position is V1, and then let's say this is V0. It doesn't mean that 9 volts battery, it doesn't mean that it's 9 volts everywhere. What it means by 9 volts battery is that if this is 9 volts, that means this is 0 volts. It's the 9 volts means change in voltage is 9 volts, not V is 9 volts constant. So this battery is bringing a low potential to high potential, bringing up charges from low to high, like an elevator or a pump, water pump, that's bringing up charges from low to high. This, as long as it's the change in voltage is 9 volts, it doesn't matter. This could have been 10 volts. Then if that means this is 19 volts, stuff like that. So here's the introduction of electric current, and then electric current is established when you have a changing voltage, and current flows from high to low voltage, right? Because you don't do any work. Remember, when you have the same voltage, if you have just the same voltage, V constant, um, you have a charge. There is no change in potential, I should say. No change in potential. You need to have a difference in height. Then electrons flow. All right. So that, and then a circuit has to be closed only when you close the switch. And the current is defined by, electric current is defined by how much charge flow per how fast. How fast the how much charge flow. All right, so, and then we use the unit that's called ampere. So I guess I'll see you in the other video.